Project question: is there a correlation between the number of women in government offices and the number of highly educated women in that region? Matt, Nick, Trish, and I all thought it would be a great idea to see if the number of women in government offices had any correlation to the number of women that were highly educated in the same region. We all thought that highly educated women were more likely to work in government positions going into this project, because it is logical to think that the higher the level of education a woman has, she is more likely to get a position in a higher ranking job, such as law enforcement, the medical field, business, and government offices. We intend to look at what percentage of students in higher education are women and what percentage of government officials are women. Our hypothesis is that in countries with more women in higher education will have a higher amount of women in government office. In order to investigate the hypothesis, we could not possibly conduct all the experiments, surveys, and censuses that we would need. So instead, we had to do research and use information that other people gathered. We used the Penguin Atlas of Women in the World by Johnny Seeger to gather our data. Page 116 through 123 gives us a quantitative data on the percentage of educated women in specific countries and the percentage of women in government of those countries. For the percentage of women, we use the data for women as a percent of students in universities as of 2005, which came from the UNESCO Global Education Digest 2007. And for women in government, we use women as a percent of members of lower or single house of government as of 2008. We took those data and plugged them into a data table on SPSS. Then we created a scatter plot and inserted the best fit line to show the correlation. We then used SPSS to find the correlation and the correlation coefficients. Then we used SPSS again to create a residual plot. We also use the equation B1 equals R times SY divided by SX and B0 equals Y hat minus B1X to find B1 and B0. The data gathered in the descriptive statistics and correlations was used to plug into these formulas to create a numerical formula to represent B1 and B0.
Looking at the data table, there really wasn't much correlation between either of the variables. The set was really spread apart. None of them really had any relation, and only about 2 of the points on the entire graph were even partially taken by the line of the least squares regression line. The R squared value was a 0.0005741, meaning that only approximately 6% of the data was related at all. 0.06% of the change in government was related to the change in female students in universities. The correlation coefficient was a 0.024, and with the correlation coefficient, either with a positive slope, the maximum value is a 1, and with a negative slope, the maximum value is a negative 1. So with a .024, it just really reinforces the fact that there was practically no correlation whatsoever between the two variables. Our LSR line equation was y hat equals 0.017x plus 17.952, meaning that when the amount of female students in the universities was 0, the percentage of women in government would still be at about 17.952%, and the slope was a .017, which means that for every 10% increase, there was only a 0.17 increase, which really isn't much at all, because it's really just a vast difference, which showed, if you look at our plot with the LSR line on it, it barely moves at all. The slope it really just looks like somebody's poorly made attempt at drawing a horizontal line. Looking at the residual plot, the data scatter is really random. There's no discernible pattern whatsoever, and it's pretty well distributed between top and bottom. So despite the fact that there is no correlation between the two events, it shows that a linear model was the best choice for the data.
Information that came from the data, we have to conclude that the data does not support our hypothesis that higher percentages of female students causes a higher percentage of female representatives in government. Well, there is a positive slope. It was very small, 0.017, meaning that for every increase in the percentage of female students by 10%, you'd expect to see only a 0.17% increase in the amount of female representatives, which is a practically negligible value. And also, the correlation coefficient, R-squared values, are so small that you might just as easily see absolutely no increase at all. You could just as easily see a decrease. So the variables are practically unrelated. A possible issue with our experiment is that the data for our two variables came from 2 different years. This might make the data be less related, but it also might actually make it more related. It might have been beneficial if we had taken the data many years apart, because that way it would give those students that we were seeing how much female were represented in universities, it would then be that same class seeing if they were then in the government. So it might have been a better idea to extend the length of time. Looking back on the hypothesis, I was wondering if there might be an issue of correlation not equaling causation. What I mean is that the amount of students might affect the amount of representatives, but just as easily, the amount of representatives might have impacted the amount of students. More female representatives might make it easier for women to attend universities. So while either way our correlation coefficients would end up being the same, it'd be a really interesting topic to explore which one causes the other. And looking back on the topic, I'd want to make some adjustments for future experiments. I think it'd be interesting to take a class of students in a country and record the percentage of males and females, and then continue to look up on that class, maybe 1, 3, 5, 10, 15 years later, to see what sort of jobs they have. See if a higher percentage of women in universities will lead to more women in higher paying and more influential jobs in the future. Maybe not necessarily government jobs, but influential jobs nonetheless.